you have like you have it's like on the coordinate plane, and like suppose the point's at like 5, 3, you have to like find all the trig functions for it.
Okay. What's the 5 equal to?
I don't know.
Cosine or sine?
Cosine?
What's the 3 equal to?
Sine.
All you have to know. In other words,
But like,
if you're dealing on a unit circle, that's always 1. So in this particular case, I would have the cosine of theta equals, well, it's never going to be 5, 3 on the unit circle. In other words, it's going to be numbers like 1/2 square root of 3 over 2. It's always going to be numbers less than 1, because cosine of theta has to be less than 1 or greater than -1. Same thing with sine of theta. So if I'm on the unit circle where the magnitude of this ray is 1, then there's no way you can have a number there greater than 1. It can't be 5. Can't be 5, 3. Now, it could be if this was longer than 1, if it wasn't a unit circle, but say it was a circle that had a radius of 5, something like that, where the radius was 5, now that point right there is actually going to be 5 cosine theta, comma 5 sine theta, with this being theta. So it kind of depends on whether you're on the unit circle or not. Usually when they give you these kind of problems, they're on the unit circle. In other words, this measurement is always 1, not something different than 1. But if I just gave you a triangle like this, and I said that's theta, this is 5, and that's 3, well, now that's x. So now the cosine of theta would be 5 over x. So it would be 5 times x, the length of whatever that is. If it's 1, then it's cosine of theta equals this number here. But always remember, sine theta and cosine theta are never greater than 1 or less than -1. If somebody tells you the sine of theta equals 1.1, that's impossible. You can never have the sine of theta being greater than 1. All right, do you have some specific problems? Because it's hard for me to generalize. It was easy for me to generalize to teach you the unit circle and to teach you how to come up with all 6 trig functions on the unit circle. I know what needs to be done there, and I know that every trig student has to be able to do that. So I knew what to do there, and I knew that was the beginning. That's really the Trig 101. Every trig student that I get, I'm giving them that same lecture that I gave you the last time we met that took about an hour, because everybody needs to know that. After that, different trig classes go different directions. So I need you to tell me the problems that we want to look at.
Okay, here, can I have like 2 minutes?
Sure.
Okay. right.
When is your final? Is your finals next week on like Wednesday or something?
No, we don't have finals because we have trimesters.
Oh, okay.
I can't find it, but like here's like an example. Like it's on the coordinate plane, and like you draw a line to the specific point, and you make a right triangle out of that point, and you have to find all the different like lengths of the triangle.
Okay, I'm happy to do that. There's the coordinate plane. Give me a point.
We'll just go with 2, 2.
Okay. So the fact that the coordinates are 2, 2 means that I have a triangle like this. That's 2 and that's 2.
Mm-hmm.
In other words, if I drop the vertical, make the triangle, now how would I figure out that angle? Is that the question? What's the question? If you want to figure out the hypotenuse, then it's the square root of 8 or 2 root 2.
No, it's like you have to find all the different trig functions, which I guess would be fairly easy. So I was wondering if we could just go through that.
The secret is to finish dimensioning the triangle. In other words, we have 2 of the dimensions, so the third one. And once you have the third dimension, now, okay, let's go through all of them. What's the sine of theta?
The sine of theta would be 2 over 2 root 2.
That does rationalize into 2 root 2 over 4, which is root 2 over 2.
Okay.
Those actually, in other words, 1 over root 2 is the same as root 2 over 2. What's cosine of theta?
Cosine of theta would be, would it be 2 over root 2 again? Root 2 over 2 again?
Yes, root 2 over 2. In other words, it's the same thing as sine. Because this is an isosceles triangle. What's tangent of theta?
The tangent would be 1.
What is the secant of theta?
The secant would be root.
Let's go back and look at what the cosine of theta is. Cosine of theta is actually 1 over root 2, right? What I'm trying to say is that if your cosine of theta has an irrational denominator, like 1 over root 2, you may not want to rationalize it immediately. Because notice, the secant of theta is just the reciprocal of that. So the secant of theta is root 2.
Mm-hmm.
But if I rationalize it first, well, I get this. And then when I reciprocate that, I get 2 over root 2. Now I got to rationalize it, and it becomes far more complicated.
Mm-hmm.
So sometimes you're better off, if you have to find the reciprocal function, you're better off waiting until you've done all 6 to do this one. In other words, we're much better off leaving that as 1 over root 2 so that we can quickly find the secant without having to rationalize it twice. You see what I'm saying?
Yeah.
All right. What's cosecant of theta?
Cosecant of theta would be root 2 over just root 2.
And the cotangent of theta?
Would be 1.
All right. What else?
That was really what we went over.
All right. Let me give you the classical trig problem. I'm going to say the sine of theta equals 2/7. Tell me all 6 trig functions. How do you do it?
Okay, so we know that
You don't
hypotenuse
need
is
to
5
put
over.
it on the coordinate plane, and I would advise not doing that. Here's the simplest way I know to do these problems. Draw a triangle, a right triangle, any right triangle, label theta. Now, dimension that triangle for me as much as you can. Just based on what I told you, that the sine of theta equals 2/7.
Okay, so you know that the hypotenuse is 7,
Okay?
and then you know that the adjacent angle is 2,
Not the adjacent, the opposite.
the opposite.
Sine is opposite over hypotenuse. Now, use the Pythagorean theorem to come up with this side.
Okay, so you would put 49 equals 4 plus x squared.
So that's 3√5. Now that you've dimensioned all three sides, you can easily go in and give me all 6 trig functions. And
Okay,
that truly is, if they were only going to ask you one trig question, this would be it. On the whole test, it would be where they give you the sine or some, it doesn't have to be the sine, they could have given you the cosine, but they give you one trig function and it allows you to dimension 2 of the 3 sides of a triangle. You figure out the third side using the Pythagorean theorem. Once you have all 3 sides dimensioned, now you can come up with all 6 trig functions. Now, it gets a little bit more complicated when they say the sine of theta is that and the cosine of theta is less than 0. In other words, that is first quadrant stuff only. The moment they add this, or they could say theta is greater than pi over 2 and less than pi. This information over here is to spot what quadrant you're in. That's it. Okay?
yeah.
So, if they gave it to me like this, just that, what quadrant am I in?
What
Where is the
quadrant
sine positive and the cosine negative?
you'd be in? You'd be in the second quadrant.
Okay, now we still draw our triangle just like before. We still dimension it exactly like before. What was this? This was 3√5. Now, every trig function, we know the cosine is what? What's the cosine of theta going to be?
The cosine of theta, or I don't know.
It's adjacent over hypotenuse. In other words, read it off the triangle. 3√5 divided by 7, right?
Yeah, sorry,
That's
it's just
the
kind of
number
spaced out
part.
there.
Now all we got to do is put the plus or minus sign on it. Is it positive or negative in the second quadrant?
It would be negative.
Okay. Now, what's the tangent of theta?
The tangent of theta would be opposite.
Get the number first and then worry about the plus or minus sign. That's the way I always do it. That's the secret to trig. It really is. Figure out the number and then the plus or minus sign. What's the number?
Okay. It would be 2√5 over 15.
What's the plus or minus sign?
It would be negative.
And doing the other 3 is relatively easy. Let me give you another problem like this. and theta is in greater than pi but less than pi, 3 pi over 2. So I'm going to ask you for all 6 trig functions. So what's our first step?
All right, so first I know it's in the third quadrant due to what you said.
That's first step, quadrant 3, based on that information up there.
Okay.
Now what?
So you
Draw
make
a triangle and label theta.
Yeah.
That's the next step, always. There's my right triangle. And I could label this thing here theta, or I could label that one theta. So that's
okay, so it doesn't matter.
a label theta so you know which acute angle you're talking about.
Okay.
Okay, now dimension this triangle for me. What's the opposite side?
3.
The adjacent side?
7.
A hypotenuse.
49 plus root 58.
Now tell me sine theta, cosine theta, tangent of theta you know, cotangent theta, secant theta, and cosecant theta. What's sine theta equal to?
Sine of theta would be...
Don't worry about rationalizing it. I know you know how to rationalize it.
Okay, so the sine of theta would be 3 over root 58.
What's cosine of theta? What's the plus or minus sign on that?
That would be minus.
What's cosine of theta?
Cosine would be... It would be 7 over 58.
Over root 58. What's the plus
And that would be
sign
0.
on that?
That would be negative.
Cotangent of theta.
Cotangent would be 7 over 3.
What's the sign on that?
That would be positive.
Okay, what's the secant of theta? Now you're going to see why it makes sense not to rationalize those early.
The secant of theta would be root 58 over 7.
What's the sign on that?
Negative.
And now cosecant?
The cosecant would be root 58 over 3.
See how much nicer it is if I don't rationalize it in the first place. Now, if I want to give all 6 of these answers, now I go rationalize. So that becomes, in other words, if I rationalize it first, then it's not so easy to come up with the cosecant and the secant. Because now I got to flip it, and then I got to rationalize it again, and I'm dealing with a double rationalization process. So don't rationalize an answer until you have to, until you turn it in. Or, you know, you're faced with multiple choice until you see the answers all have been rationalized. So it's as simple as this. This really is, this question will take you a long way, where they basically give you one trig function. It doesn't matter which one they give you. And they tell you enough information so that you can spot the quadrant that it's in. And then all you do is the same thing every time. You draw a right triangle and you dimension it based on that. Then you use the Pythagorean Theorem to figure out the third side, whichever it might be. Once you have all 3 sides, now it's a piece of cake to come up with all 5 other trig functions.
All right.
And notice that I didn't draw the coordinate plane or anything on these. It's not necessary to do. It's so simple to do it this way that you always want to remember to do it this way. In other words, you essentially work it out as if it's first quadrant, always. when I dimension this thing as 3 over 7 and then root 58, I'm basically looking at a first quadrant. If I didn't have this information over here, then all 6 of my trig functions would be positive. I would just consider them all to be in the first quadrant.
Mm-hmm.
So when they give you this additional information, and sometimes this information doesn't come like that. Sometimes
How would it come?
say the cosine of theta is less than 0. Well, there's only one quadrant where the tangent is positive and the cosine is negative, and that's the third quadrant. So this might be the only additional information they give you instead of up there.
Wait, could you go over that? Because that doesn't make sense to me.
Okay. If we draw our unit circle, all students take calculus. Which quadrant is the tangent positive and the cosine's negative? There's only one.
The third quadrant.
Right.
But how do you get that from just cosine of theta is less than 0?
Well, that means the cosine of theta is negative, right?
But wouldn't it be negative in the sine too?
Correct, but the tangent wouldn't be positive.
How do you know the tangent's positive? Oh, okay. Yeah, that makes sense.
You're taking both of those pieces of information to figure out the quadrant.
Okay.
In other words, it's where the tangent is positive and the cosine is negative, and that's only the third quadrant.
Mm-hmm.
If I would have said the sine is positive and the cosine is negative, then that's the second quadrant. Has to be. In other words, whenever they give you two different functions and they tell you which one's positive and which one the other one, it spots it to a given quadrant. What if I said the sine of theta was 3/7 and the cosine of theta was greater than 0? Which quadrant is that?
Cosine of theta is greater than 0. That would be in the first quadrant.
Yes. So
that makes sense.
that's the trick, is all of these problems, they always give you one trig function,
Mm-hmm.
and they give you enough information to figure out which quadrant it's in. But you can wait and figure that out at the end of the problem. In other words, I can start every one of these problems by just drawing the triangle and labeling theta. In other words, if they tell me the tangent of theta is 3/7, I can draw all of this. And I can figure out all 6 trig functions. I just can't figure out their plus or minus sign until I figure out what quadrant it's in. And I can figure out what quadrant it's in by whatever information they give me over there.
Mm-hmm.
All right. Jake, unless you have any last questions, I'll let you go.
No, you answered all of them. Thank you.
Okay, yeah, that'll take you a long way, because that is a very, very common question on trig tests, or just trig quizzes in general, where they give you one trig result, and they tell you enough information to spot the quadrant, and they want all the other trig answers. And they're really, they're easy problems. They really are not, there's nothing hard about them as long as you remember the methodology. Draw that triangle and label theta. And then go from there.
All right.
All right, Jake, I will put this new phone number into my contacts list for you, and from now on I will text it directly to this phone number.
Okay, sounds good.
All right. Talk to you next Tuesday.
All right. You have a good day.
You too. Bye-bye.